Mechanical control is different measures implemented to prevent the entry of flies or to eliminate them by means of different devices or equipment. It can be a good control measure when combined with chemical and other control procedures, for example, fly traps and screens. Chemical control. Control methods where different tested chemical compounds are used to eliminate or reduce fly infestation. Methods include sprays, baits and feed additives that are specifically formulated as adulticides or larvicides. It is important to use the correct type of chemical on the correct surface. Rodent control. Rodent control programs need to consider the biology and behavior of different rodent species. Rodents are creatures of habit and have a strong social structure. Different species have different biology and habitat. By observing the morphology and droppings of rodents, one can determine which species is infesting your farm or facility. The importance of placing the correct type of rodenticide at the correct location cannot be overemphasized. This is the reason why the traveling routes of rodents should be investigated. Rodents are nocturnal creatures, meaning they normally travel and feed at night, and most of the times in a defined home range. They stay wherever they can find food. This also means economical loss, as feed is wasted daily by these pests. Other areas of economical impact can include the damaging of property and equipment, electric cables, packaging material, water pipes, and insulation. They are also important disease vectors and contaminate the area with their urine, feces, and hair. Physical control methods include discarding of spilled feed and litter, storing of feed in sealed bins, keeping grass short around houses and facilities, maintaining of good sewage systems, and limiting access routes into houses or other facilities. There is a wide range of chemical control products available. Bait stations should be used to keep bait out of reach from non-target species. These bait stations should be placed on the traveling routes, and baits should be regularly replaced with fresh bait. Always dispose dead rodents as soon as possible and as often as possible. Aerial disinfection. A fine mist of disinfectant can be sprayed over birds during the cycle to reduce cross-infection and secondary bacterial infections. For example, E. coli septicemia. Secondary bacterial infections commonly occur following respiratory virus challenges, for example, infectious bronchitis, or bacterial challenges, for example, mycoplasma infections. The correct formulation and dilution rate is important when doing aerial disinfection while live birds occupy the house. Mortality disposal. Mortality should be disposed of in a safe and environmentally friendly manner. Carcasses are sources of possible disease-causing organisms and can cause contamination of surrounding areas. Several methods can be followed to dispose of mortalities, and each farm will have to implement the most practical and safest method possible for that specific farm. Burial, freezing, incineration, and aerobic composting are all methods of disposal. Mortality pits should be a distance from the sites and should be out of reach of scavengers and predators. Terminal Broiler House Cleanout and Disinfection Program. Farm cleanout. A proper cleanout program is critical in disease prevention, and attention to detail should be given to assure an effective cleanout and preparation for the new cycle. The ideal is to work on an all-in, all-out basis, and to have sufficient downtime to give enough time for dry cleaning, repairs, washing, and disinfecting. It is recommended to allow at least 10 to 14 days for proper cleanout and resting of houses. Removal of litter, organic material, and dust. It is ideal, though essential, that especially broiler farms should work on an all-in, all-out system. Should farmers or companies feel that a continuous supply of birds is needed for marketing reasons, the different age groups should be kept at different locations, being at least 400 meters apart. Personnel should also be limited to specific houses in order to prevent cross-contamination. On layer farms, manure belts deliver the manure to the end of the cage row, where it crosses conveyors to remove it from the house and to reduce ammonia and flies throughout the cycle. Do not use water to remove the manure from these belts. Run the manure belts and remove the manure with scraping equipment. Place the manure in the tractor trailers for removal. The high-rise layer house with deep pit storage is generally regarded as one of the most labor-efficient for manure management. This is, however, dependent on good drainage, prevention of water spillage onto the manure, and good air circulation over the manure mass. Proper disposal of dead birds and a good fly and rodent control program are essential. The first important step to be followed when starting a clean-out program is litter removal. Litter must be removed as quickly as possible at the end of each cycle. When litter is removed, it is important to cover it in order to prevent spreading and contamination. This can be done by transporting it in bags on a covered trailer or truck and should be disposed of at least 1 to 2 kilometers away from the closest site or farm. No litter should be on site once washing has begun. Microorganisms are contained in the dirt, including litter, organic material, and dust. Removal of organic material is therefore the first step to reduce the greatest number of microorganisms and is essential in preparing the house for cleaning and disinfecting with a specific chemical. Chicken manure contains high concentration nutrients, particularly nitrogen. Manure has a positive effect on crop growth and yield and is commonly used as fertilizers for agricultural land. The manure is also a source of nitrogen to cattle and is commonly fed as a non-protein nitrogen source. It is important that should these uses of chicken manure be implemented on the farm, it should be properly dried and not be used within a distance of at least 1 kilometer. Dry cleanout. Dry cleanout follows litter removal and is just as important to prepare houses for washing and disinfecting. Special attention should be given to problem areas, especially cracks and uneven areas on the floor and wall, the roof, beams, and corners. The correct equipment is essential in order to be able to effectively clean houses. Make use of brooms, dusters, or any other equipment that can be helpful. Cleaning of litter spillage and other organic waste outside and around houses is also critical and should be done as part of the dry cleanout step. The removal of as much possible organic material eases the effectiveness of chemicals used. Washing and disinfecting. Before effective cleaning and disinfecting can be done, a few important factors should be considered when cleaning chemicals are chosen and prepared. Formulation. The active ingredients of detergents and disinfectants should be compatible for the specific purpose it is intended for, namely activity in organic material, specific disease or pathogen outbreaks, wood, environmental controlled houses, open-sided houses, etc. Concentration. It is critical to follow the manufacturer's recommendation on the concentration of chemicals. Make sure that the correct procedures are followed when diluting the chemical. Simplify the measuring of products for staff members in order to encourage correct use. It is also important that workers are trained on the handling, safety, and application of products. Contact time. Chemicals are effective in decontamination at a specific minimum contact time. Make sure that attention is given and procedures followed in order to allow an effective contact time on surfaces. Temperature. Warm water enhances the efficacy of chemicals that also allows better degreasing of surfaces. Farms that do not have access to warm water should use products that work effectively in cold water. Susceptibility of the microbe. Use broad-spectrum disinfectants with active ingredients that are effective against non-enveloped and enveloped viruses, bacteria, fungi, and bacterial spores. Microbial load. The dry cleanout step is essential in order to improve the effectiveness of the chemical by reducing the microbial load contained in the organic material and dust as low as possible. Chemicals should be safely stored and protected from direct sunlight. All products must be registered and labeled properly and accompanied by safety and technical data sheets. Washing. After a thorough dry cleaning process, the houses must be rinsed out with clean water before applying the detergent or soap. This contributes to efficient cleaning and removal of dirt. Always use a detergent or detergent disinfectant that is compatible with the disinfectant intended to use for disinfection. Different application methods and equipment can be used, depending on the facilities and resources available. Detergents act as a surfactant that lower the surface tension of aqueous solutions in order to increase the effectiveness of disinfectants. The use of a high-pressure washer is, however, recommended. Detergents can also be applied via a foaming lance, especially on very greasy surfaces, like the feeder lines, feeder pans, and drinker lines. Allow it to soak for 15 minutes and rinse with water. A detergent degreaser or a sodium hypochlorite-based product can be used for greasy areas. Special attention should be given to problem areas, and extra effort or manual application and cleaning might be necessary at difficult-to-reach areas. The hygiene of feeders and drinkers, as well as water pipes, is critical. Make sure that all debris, scale, biofilm, and fatty layers are removed and cleaned from these areas properly. The outside of houses and curtains should be washed first, whereafter the cleaning team can proceed to the inside. The direction and order in which the washing or disinfecting process takes place is of great importance. Start by washing the roof at the front of the house and move along the roof to the back. The walls and floor can now be washed, starting from the back and moving towards the front or opening of the house. Dirt and wastewater should be moved to the outside of the house by using brooms, squeezers, and other relevant equipment. Water lines and feed systems. Water hygiene plays a major role in animal, especially poultry, health. During the cycle, biofilm builds up in pipelines, tanks, and reservoirs. Biofilm is a slimy deposit that can develop in any system where water is present for prolonged periods of time. This is especially the case where additives in the forms of vitamins, sugars, medication, and organic compounds are used. This can lead to the malfunctioning of water systems, as well as an ideal growth medium for microorganisms, which in turn can increase the risk of infectious diseases. Depending on the water quality, calcium buildup called mineral scale, as well as rust, can also form and act as a growth medium for certain microorganisms. It is therefore important to give attention to the cleaning of water systems continuously, as well as at the end of a cycle. During the cycle, water treatment can be continuous by adding chlorine or chlorine bromide tablets to the water, or a safe water sanitizer that can limit biofilm buildup or disease spreading as a result of poor quality or contaminated water. These products should be removed prior to water vaccination. At the end of a cycle, remaining water should be drained from the system and feed systems should be cleared. The header tanks should be filled with water and a proper biofilm removing disinfectant at the correct concentration. This can remain in the tanks and allowed to soak in the water lines for the recommended time. Thereafter, the system must be flushed and thoroughly rinsed with clean water until no disinfectant is left. The same procedure can be followed with a descaling product. In the case of bell drinkers or other drinking or feeding systems, a recommended detergent disinfectant, as well as a descaler if necessary, can be used to manually clean the equipment. Also rinse all equipment with clean water after disinfecting. First remove biofilm and active HP, then descale with vet scale. Always ensure that water header tanks are well covered and protected from pests entering and contaminating water. All leftover feed must be removed from the feed troughs and pans, feeder lines, tube feeders, and other feed systems and containers. Spilled feed must be swept up and removed. No washing may commence if there is still feed left at any point in the system. Wash the feed system with a detergent disinfectant using high pressure during the washing step. Always ensure that feed bins are dry before receiving and placing feed. Application of insecticides. Insecticides can be sprayed inside and around the houses. An initial treatment can take place following the wash step and a second before the placement of new bedding. Ensure that all holes in the roof and around the house are sealed and that the doors are closed firmly. Long grass around the house must be cut, and insecticides should be used according to manufacturer's instructions. Repairs and maintenance. The ideal opportunity for structural repairs and maintenance is during this time when the houses are empty, cleaned but prior to disinfection. If there is any accumulation of organic material in the houses while repairs are done, it should be cleaned before the disinfection process. Disinfection. Once all the houses have been cleaned and the site has been cleared of contaminated material, disinfection can follow. The choice and application of disinfectant is important, and dilution rates should be adhered to. Glutaraldehyde quaternary ammonium compounds, QAC, or formalin-based disinfectants are effectively used. Equipment used for application should be effective in reaching all areas, and again, it is necessary to keep surfaces in contact with the disinfectant for the recommended contact time. A low-pressure pump with a foaming lance is ideal. Ensure that all surfaces remain wet for at least 30 minutes. After disinfection, the houses should be closed for 24 hours, whereafter foot baths should immediately be placed to avoid recontamination. Good quality, fresh bedding can be placed when all surface areas are dry. Fumigation and fogging. Fumigation should be undertaken as soon as possible after completion of disinfection. Surfaces should be damp and the house should be heated to 21 degrees Celsius. Fumigation is ineffective at lower temperatures and at a relative humidity of less than 65%. Doors, fans, ventilation grills and windows must be sealed. Manufacturer's application instructions and safety measures regarding the use of fumigants must be followed. After fumigation, the house must remain sealed for 24 hours with appropriate no entry notice signs clearly displayed. The house must be thoroughly ventilated for 24 hours before anyone enters or placement of chicks. Protective clothing, i.e. respirators, eye shields, gloves and protective clothing must be worn. At least 2 persons must be present in case of emergency. Fogging is a popular alternative to fumigation. Most disinfectants can be fogged, and relative application and safety procedures should be followed. External areas. A 2 to 3 meter range clearance must be maintained around houses. This area should also be treated with a disinfectant as recommended by the manufacturer. Pay attention to the house entrances and keep grass on site short and neat at all times. Risk of infection and risk management. Hygiene monitoring. Hygiene monitoring should be done on a regular basis following cleaning and disinfection of houses. This can give an indication of the effectiveness of the cleaning process and monitor the microbial load remaining after cleaning. Swabs, contact plates or contact paddles can be taken from several areas in the house. For example, floor, wall, roof, drinker line, feeder pan, etc. These will be handed in at laboratory for bacterial culture. Water samples should also be taken regularly from different sites for bacterial analysis and heavy metal analysis. Biosecurity audits can be performed on a regular basis. Risk assessment is essential to ascertain the measure which should be implemented to manage risks and therefore ensure high standards of biosecurity and flock health. This is done by means of HACCP strategies, which identify areas of high risk for introduction of pathogens into the system, control methods, and monitoring of the production line from farm to fork.